In this video, I will be explaining about the famous machine learning framework Scikit-Learn. It is more suitable for traditional machine learning models like classification, regression, clustering, dimensionality reduction, model selection, pre-processing. So in this website, they provided the algorithm supported by them, right? And in case of deep learning models, it is better to go with Google's TensorFlow or Meta's PyTorch, okay? This scikit-learn is more suitable for traditional machine learning models, okay? But it's a very simple thing. It's a Python library. The Python library is known as sklearn, okay? It is built on top of Python's NumPy, SciPy, and Matplotlib libraries, okay? So it is more suitable for small scale projects, okay? And it will be very simple and easy to use. So better as a beginner, you can try many things with scikit-learn, okay? In case of classification, it is just identifying, in case of spam detection, identifying whether it's a spam email or not. It's using various algorithms, and we can use them in scikit-learn, okay? So just we can choose our record model and then we can train it and we can use it, okay? Similarly, regression. Regression is predicting the continuous values, like in case of stock prices, like predicting the upcoming stock price value, okay? So it's a continuous value prediction. And clustering is just grouping similar objects into sets, okay? For every kind of thing, there is related algorithm, okay? And based on our recommend, we can choose appropriate model, and then we can use scikit-learn for training it and for using that trained model, okay? Similarly, it is applicable for dimensional reduction, model selection, and pre-processing. But this scikit-learn is not that much suitable for deep learning models. In case of deep learning models, we have to go with TensorFlow or PyTorch, okay? Let me just show a very simple example to explain about scikit-learn. Let me just take a classification thing, okay? I already put the code here in the Google Colab, okay? Dataset also, sklearn is providing datasets also. We are just importing the datasets. In case of this example, we are going to use the iris dataset. It's like detailed support some flowers, iris flowers, okay? It will be keeping the dimensions, sepal and petal dimensions, and labels as flower type, okay? So based on this training data, our model will be trained, and then we can use some sample data for getting the prediction, so that the model can identify the flower, right? It's a very simple example just for explaining this sklearn. I'm just taking this example, okay? So first we are importing the data sets, okay? And mostly for training any kind of model, we got to use some training data as well as test data, right? For training any model, first of all, we have to choose that algorithm, okay? And then we have to provide training data as well as testing data. Then we have to train the model using the training data. Then we have to evaluate the model using test data. Then only we will be able to start using it for prediction, actual usage, okay? This is the very basic of any kind of AI models, okay? So in that perspective, sklearn is providing this train test split, so that it can split the data like train data and test data automatically. So it will help us to save time. And this algorithm, decision tree classifier, it's a classifier algorithm, right? So sklearn.tree, from that package we are importing this method, and metrics for measuring the accuracy, okay? For any kind of model, we have to measure the accuracy. It's some kind of testing. Then only we will be able to confidently start using that model, right? So we have to get that data, and then we have to train it, and then we have to test it. Then only we will be able to use it, right? This is for any kind of model. Just I'm highlighting here again, okay? In case of sklearn, what I'm trying to say is it's providing all the supporting libraries so that we can do everything very easily with this sklearn itself. Okay, we are just loading the iris data. So normally, as a standard way, x is always features, right, and y is labels. So for any kind of classification, we have to say, in case of dog, we can say that it has 4 legs, okay, 2 ears, like that, right? Some features of the object, then the label dog. Cat means what are the features of cat, and then label like cat. So it is a very fundamental way of doing this kind of data training. So for that, we normally use x for the features and y for the labels. So similarly, in case of this iris flash data, features are like length and width of sepal and petal, and y is obviously label flower type. Okay, and next step is we have to split the training data and test data. For that, we are using this train test split. Okay, so we are giving the x file as a argument, and it will be just splitting it into x train and x test, y train and y test. Okay, so it's obviously it's simply it's splitting the data set into 2 things, train and test. Then we have to choose the model. Here we are choosing the decision tree. Okay, so decision tree classifier model. Okay, and next step is using fit, we have to train the model. So while training the model, we have to provide the training data, right, these features and then label, right? So training data, okay, x train, y train. Okay, as I said earlier, we have to measure the accuracy. Okay, it's kind of evaluation before you putting it for actual usage. Okay, so here we are using this accuracy score. So now we have completed loading the data and then splitting it into training and testing, and then creating the model, and then training the model using training data, and then doing the prediction, okay, with that trained model, and then based on that data we are calculating the accuracy. Okay, once we are satisfied with the accuracy, we can move forward with actual usage, predicting any kind of new samples. So the new sample, we are just using this sample example. Okay, it is the length of sepal and the width of the sepal and length of the petal and the width of the petal, like that. Okay, so if we give these numbers as a features of this sample flower, then we can just call this predict for predicting the new sample. Okay, using this trained model. It's very simple, right? But it covers all the basic things of training any kind of machine learning model. So this is the very fundamental, any kind of, even for computer vision, everything, the basic is same. Okay, so with the help of sklearn, we can easily learn it. Okay, so we can just run it. Okay, so the accuracy is 100%. Okay, so we can move forward with the actual usage. Actual usage is for this sample, it is classifying it as setosa. Okay, suppose if we change that parameters, it will be detecting as some other thing. Maybe I have some other sample, so it is some other thing. Okay, maybe we can just randomly change. Okay, so it's able to predict the flower, okay, based on the dimensions of the flower. Okay, that's it. It is about sklearn. Start using it for practicing. So, but in actual usage, as I explained earlier, for any kind of deep learning, it is better to go with TensorFlow, because that are providing like production implementation, that delivery, everything they make easy. But in case of sklearn, we can learn it easily. Okay.